All right, so we up and running on the inside. Nice. Okay. Yeah, talk to me. Yeah, I saw it the other day, boy. I couldn't do anything with it, but I'll try to organize it tonight, right? Maybe I can try and do that while they're doing some work. Let me see what's going on. A tangent is a straight line that touches a circle at one point. So TA and TB are two tangents to a circle, and they start at the same point, T. And what we learn on Monday is that TA and TB will be equal in length. Yeah. So so TA and TB are equal in length. Yeah. But go ahead. Question. AC and CB. So as in like this length here and this length here? Nah. Which rule is that? Well, this is a radius here, and this is a radius here. Those two lines aren't radii because radii start at the center of the circle, not so? Yeah, they do. They do. All right, good. I'm not sure. Oops, sorry. Supplementary means that the two angles add up to 180 degrees. Oh, yeah. Like, I have no idea what this means. Like, I know it. Right, guys, so we're in math class now. We're working some circle geometry or circle theorem. So, do you know how to find angle A and angle C given the information in the diagram here? Right. Oh, it's Logan. Evening, Logan. Yeah, this is the first question, so you miss anything. So in this question, we have one angle of 48 degrees on the outside here. We know that these two tangents are equal in length, and we also know that these two radii are equal in length. All right. What time today? All right. You all here on it's Friday or Saturday? You're coming again? It's Saturday. Okay. All right. Cool. Yeah, because she was telling me it was supposed to be like in the afternoon or something. All right. Cool. All right. Okay. Enjoy your evening. Thank you. Yeah. Did you bring? So the question I have for you is: did you bring your rules from Monday? Well, right. That could work. That could work. Because on Monday, we went through a series of diagrams here. We said first that if there are two tangents that start from the same point outside a circle, right, the distance from the point outside to the points of tangency is the same. So it means that those two lines, the pink and the green, are the same. And if we have two radii meeting them there, of course, in any given circle, all radii are the same length, not so? Right. Now, does this diagram look somewhat like we have here? We have a couple extra lines here, right? Okay. But if we go back to this now, we also see a couple things here. Why? What are those angles there? Those angles are 90 degrees. Because that's a rule we learned last week Wednesday. The angle between a radius and a tangent is 90 degrees at the point of tangency, right? So, just by the way, if you observe that we have a shape here with how many sides? 4 sides. And what is the technical term for a 4-sided shape? A quadrilateral, right? And what is the sum of the interior angles of a quadrilateral? 360. Okay, cool. Now, in this quadrilateral, we have 2 of those angles that we know are each 90 degrees. That was 90 plus 90. 180, which means that if you add all 4 angles, you get 360, and 2 of them adding up to 180, the other 2 must also therefore add to 180 as well, because 180 plus 180 is 360 degrees. All right, so we'll go back here. So what we could pencil in here, right, is that this angle here is 90 degrees. This angle here is 90 degrees. Right? So again, if you consider the yellow lines and the green lines, we have that same kind of quadrilateral we saw here. Not so? Not so? Right. Okay, cool. Right. Right. This is not closed captions. Right? Right. So therefore, if we add up these 4 angles, we get 360. We know that adding up these 2 will give us 180 because they are both 90 degrees, which means adding up these 2 will give us 180 as well. So we could find A by doing what? Taking 48 and subtracting it from 180, because those 2 angles are supplementary. All right. So let's zoom out and see if we could notate that, right? Let's use the same color, no? Why not? Right. So to find AOB is equal to 180 minus 48 degrees, which gives us 132 degrees. And the reason here that we could put is because AOB and ATB are supplementary. Like here, you see it now? Everything seen and hearing? Okay. Now the next angle they want is that angle C. Okay, good. That's what let me know. Right. Now, if we focus, let's take out some of the extra colors here, right? If we focus on, hold on, let me get, oops, no, that's not what I wanted. Sorry about that. Let's do a kind of a bright blue, right? If we focus specifically right. Caribbean coolie. Okay. Right. If we focus specifically on the shape outlined in blue, how many sides does that shape have? Same 4, right? So it's a quadrilateral. But is it a cyclic quadrilateral? No. Why? Because not all of the vertices touch the circumference, right? One of the vertices is at the center of the circle, right? For it to be a cyclic quadrilateral, all 4 vertices will have to touch the circumference. Okay. But there was a rule that we saw that looked like that. If you rotate it, right? Let me see if I could rotate it. We turn it this way. Does it kind of look like the rule? The question we have just now? And what is the rule there for? The rule is that the angle at the center is double the angle at the circumference, right? So the angle we are looking for is the angle at the circumference, which is double the angle at the center, which is this angle here, right? Just for the sake of simplicity, let's just call it angle B, right? So the rule is that B is equal to 2 times C. The angle at the center is double the angle at the circumference, all right? But here's my question. How are we going to find angle B? Yeah, B is equal to 2 times C. But how do we find B? We're looking for C. That is correct. Say that a little louder for them. 360 minus the 132. Because what we have here, basically a circle, right? We have the name of the rule is the sum of the angles at a point is 360, right? So if you consider that the orange part, the angle B and angle A, basically form a circle, right? The total degrees in a circle, as we said, is 360. So if we have the portion, the number of degrees for A, we could find the number of degrees for B. And after we find B, how are we going to find C? Divided by 2. All right, so I'll give you a minute or so to work that out, and then I'll write it up. Let me just double check my rule. All right, so ACB is equal to 360 minus the 132 divided by 2. Right, so we'll put a little 1 here and a little 2 here so we could identify the rules, right? Now 360 minus 132 I think is 228. Anybody could corroborate that? Right, so 228 degrees divided by 2, 114 degrees. Right. Right, now let's cite our rule, shall we? Come on, man, Philip, do that. Oh, you could do that. Yep, that's how you get half of your marks. All right, so rule 1, the 360 is, yeah. They don't say it, but it's supposed to be understood, right? There was one time they asked for it, but the way they asked it was so awkward. It's like, what are you doing? You know? Yeah. All right, so angles at a point, sum to 360, sorry. And 2, angle at center is double the angle at circumference. Right? A little abbreviation going on there. Hello, Chris boy, and the real J boy going on. As opposed to all the fake G's. Say that again, sorry? Yeah, like if for example you have lines going like this, right? That's a point there, and you'll have this angle here, that angle there, this angle here, and that angle there, right? So the sum of all those 4 angles is 360. Right? If you have 2 lines intersecting, right? These 2 angles are equal, and these two angles are equal. But the sum of all four of them is 360. And that's correct. Yeah. One second, Jerry. Right. So we found A by doing 180 minus the 48, right? To find B is 360 minus the 132. And then the angle at the center, B, is double the angle of the circumference. So if we have this angle, that's double C. So to find C, I have to find half of that, which is why we divide by 2. Yeah? Okay. Yeah, Jerry. Sorry. Go ahead. Yeah. Oh, the rule for the right angles is the angle between the angle between a radius and a tangent is 90 degrees. That was actually last week. That's this rule here. The angle between tangent and radius is 90 degrees. You okay with that? All right, cool. All right, so I'm going to this one now. Hold on, can I send this in the chat? I'll hold off on that. Right. Let me just delete this piece here. Cut that out. Yeah, want that. Put that there. Right. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. I will do 10. Print. Right. Okay, cool. Right, and I'll tell you what I want inside of here. Right, so I'll go back here for a second in case anybody's still copying some stuff down. Now, looking at my experience from last year, and they were quite a lot more. Huh? I did 10, so you could keep one, right, Mishka? But the first page was actually a copy of the last question. So when you put it out, just take out the first page, and I'll hold it. Yeah, that one was the one we just did. That's number 7, right? So we're number 8 now. Oops. Right. So in number 8 now, we have to find, yeah. Hold on. Sorry, no, sorry. Yeah, no, my bad. Yeah, we are. So we are finding, let's call this angle X, and we'll call this angle Y. No, you will not. I would say spend your time answering questions first, and then you could go back and do your coloring after. What's that? Oh, well, you got 0.5 out. That's all right. 0.5 is okay. Right. All right. So this question was basically a carbon copy of the previous one. All right. So any volunteers tell me what X? Uh-huh. 180 minus 53 degrees, right? And that gives us what, 127? Right. And the reason for that is because AOB and ATB are supplementary, yeah. So AOB is this angle here, and ATB is the 52-degree one. All right, cool. All right, and what about angle Y? What would we use to find angle Y? We'd have to first find an angle on the outside here, which is, let's just call it Z, right? Right, why? Because the angle at the center is double at the angular circumference, right? So we could even say that, we could say that Z is equal to 2Y, right? That's the rule. Angle at center is equal to double the angular circumference. But to find Z, how do we find Z? Correct. This is 127 here. And if you look, this kind of gives us a whole circle. And, well, the sum of the angles at that point is equal to 360. So 360 minus 127 would give us, what is that? 233. Right? Let's call that rule 1. And then to find Y now, we could take the 233 and then do what? Divide by 2. All right. Sorry. So therefore, Y would be equal to Z divided by 2. So that's what, 111.5? No, 116.5. Sorry, thank you, yes. Right? And don't forget to cite your rules, right? So in the first instance, sorry, one sec. Different color. Come now, man, Philip. Do not. I'll do the purple with the green. Apparently, green and purple are inverse of each other, so they stand out. It's the highest contrast you could get. Yeah. I saw that somewhere. No, yeah, purple cancels yellow, isn't it, right? With the banana, some. Yeah. I think get the color wheel and see which ones really work that well or not. All right, cool. All right, so. All right, so 1. So rule 1 was that angles at a point sum to 360 degrees. Right, and then item 2 was angle at center. Is equal to 2 times angle at circumference. Yeah, okay. Sorry, 360 minus 127. Yep, that's correct. Good job. All right, Google Meet, just kindly give me a G if you guys are good with the solution for this item, yeah? And I know I'm not asking, and it's the second question, but asking. All right, 1, 2, 3, 4. Right, so 4 out of 5 people. All right, so Jerry, you'll let me know when you get a chance, right? Okay, and in class, people, are we okay with that? Does anybody have any questions? You okay? Yeah? All right. Okay, we're going again then. All right, I'm just. Yo. Ah. Right. Wednesday. Okay. All right. Right. Wow. Yeah, just give me one second. I want to put this to print first, right? Just give me a minute and I'll go back, right? And when it printing, I'll, of course, well, let you see the business. Yeah, there you go. All right, cool. If I have a, oh, it's pretty good actually. Oh, you finally got the scissors? Hey, princess, what vibes? Doing some circle geometry. Test your mind. Test your brain. All right. Okay, and let me tell you what we're looking for inside of here, right? Y and Z. Right. That's angle X. That's angle Y. And that's angle Z. Right, so we're looking for those three angles, X, Y, and Z. All right. Just to put in some little extra things here. Come on, man, stop doing that. Correct? So those two lines are equal, TA and TB. Yeah. OA and OB are radii, so they also are equal in length. Right. And we know that the angle here is 90 because it's between a tangent and a radius. And down here at B is also 90 degrees. What's that? Yep. Well, 1 second, right? Okay. Yo. Oh, uh-huh. Yeah, yeah, the arrowhead, right? Does that help? All right, cool.
Why?
Oh, no, it's 1%. I was trying to figure this as a connection between anything. Because when you take this from one end, you get this. So when you find half, you get this.
Yeah.
Just move it in this way, and I'm going back down, you have the arrowhead. Right, so which one you have?
Yeah. Yeah. Yeah.
No, sorry, that's Z. Oh, I read it.
This
Right.
so
So
Z is 50. Z is 50.
yeah, that's good for your rules. You just put it on that sentence. You just put it. Right. So the whole thing is 50, right? Some of the rules are just too cumbersome to write. So that's why like, I just say that this angle, this is something. It's showing us the whole thing. Right? So when you get 130 here, you're subtracting. Right, yeah. So that's this. Yeah, that's the sum of the angle point. So if you have like a circle, you can go total degrees in a circle is 360. When you kind of break it up into pieces, we call it sum of the angles of a point, 360. So that 360 minus that gives us 240. Right, and then, right, so this one is half of that, because the angle at center, this one here, is double the angle of this one. And then these two, yeah, are essentially, that makes us the opposite angles. Let me see what they. Okay, cool. All right. Not what BI. Right. So first things first is that we could say that this angle here is also 25 based on the nature diagram, right? Because you have this triangle here and this triangle here having three sides in common, which means that they are congruent, perfectly congruent, right? Which means all the corresponding angles equal as well. So that's so the whole angle here is 50. So we could find this angle here, 180 minus. So let's just call that theta. Here, all the way to here. So that's 180 minus 50, which will give us 130. That's 130. Sorry. Right. So then from there you could find x. You could even find y from that 130 as well. And then from either x or y you could find z. Right. So you have different ways to go about finding the answers. Right. Okay. So first things first. Let's just put the kind of, I don't want to call it the key, but the kind of the lead domino. Right. So angle AOB, obtuse, because the angle on the back is also AOB, but AOB reflex, right? So A will be obtuse is equal to 180 degrees. Sorry, oh, I said it blank. Sorry. Happy child, we're going on, right? Minus the 50 degrees. Which is 25 by 2. Right? 180 minus 50 is 130 degrees, right? And this is because angle AOB and angle ATB, right? The angle at center and the angle between the two tangents are supplementary. Right? That means they add up to 180, right? So now that we found that 130, we could find x very easily, right? So x would simply be equal to 360 minus 130, which is 230, right? And this one is angles at a point, sum to 360, sorry. Angles at a point, sum to 360 degrees. Right? Now to find angle y, right? So angle y, if you look at it, it's the kind of arrowhead rule, right? Which means that the angle at center, that same purple angle AOB that we found initially at the top in the purple, right? AOB is double ARB, the angle y. So if you want to reverse it, you could say that to find y, we have to take the 130 and then divide by 2. That'll give us 65 degrees. And the reason here is because angle at center angle at center is double or 2 times angle at circumference. Yeah, I'm abbreviating. Try to not abbreviate if you could. Sniper Kid Boy and Mrs. James. Ah. Right, now to find z, we have 2 ways we could, well, I'm pretty sure we have more than 2, but we have 2 ways that are very, what's the word, simple to use that we could use, right? So first things first, we could use the same rule with the green and use that x, right, x and z. X is 2 times z, right, because x is the angle at the center, all right? So to find z, right, we could say that as, 230 divided by 2, thank you. Which is 115 degrees, right? Same. So I'll just put same rule as above. Right? Now the other way to do it is if we were to, hold on, give me a second. Yeah? Yes, because they are opposite angles of a cyclic quadrilateral. So yes. Yes. Yeah. So like I was saying, I was going to show 2 ways to do it. Yeah. Right? So if we focus on the quadrilateral ARBS or ASBR or RAB, whatever, right? That's a cyclic quadrilateral. All 4 vertices touch the circumference, which means that the opposite angles are supplementary. So y and z are supplementary, which means they add up to 180 degrees. So you could use that rule as well. Right, so for z, you could say it's equal to 180 minus y, which is 65 degrees. That'll give us 115. Yeah. If in your work and you put refooted diagram, it might help. Okay. What's up? I should. Don't know where they are. For which years? You same one from yesterday? 20. What, May or Jan? Give me 2 minutes. I'm gonna get them next question. No, I'll check it, right? Jan 23? Alright, paper 1, right? Yeah. All right, so this one is opposite angles of a cyclic quad are supplementary. Now, Nyla, I can't guarantee that if you put refer the diagram that they actually will. All right? It does. Because as my friend Kirk explained to me, the person marking the paper is supposed to look at your paper and look at what you've written. Right? That's their job. Right? So, for example, like if we mark up on the diagram, they can't take it into consideration. Right? So, if you do mark up on a diagram, I would say refer the diagram. But I mean, I'm not sure what degree of specificity you have to use, right? So just yeah, as best you can, as clearly. Okay, right. Google Meet. Sorry, just kindly give me a Genie certificate with number 9, please and thanks. Right? And for this one down here, guys, you don't have to put both of them. It's either or, right? You don't have to put both of them. And either one of them is perfectly fine. 1, 2, 3, 4. One more person. Right. Okay, cool. Didn't I have 8 people? Somebody jump out again? Alright. Alright, so let me get that out. You ought to come out too. You could get this up here. Go there. Go there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, cool. Alright, cool. Right, now number 10. We want X and Y. Okay, so this one is slightly simpler. Yes. Or ID key. Just kidding. I'll have to go up to some wallet, but that should be a problem. Yeah. That's today and Monday, right?
Yeah.
Okay, cool.
Those are cute. Those are cute. I like those. Blue. Well, it depends. Like how deftly you want to. Maybe I'll keep the beat. They look really cute, but I think blue looks nice.
Very well.
So you do it, huh?
Yeah.
All right. How are we going there, guys? How are you feeling with that? Seeming familiar? The rules, yeah. Yeah. Okay. Cool. No problems. Hey, wife. Hello, wife. How are you? How are the boys?
Well, Chris, I joined your art class yesterday. You didn't notice.
I'm not sure. Yeah, that's number 11. Yeah. You could just hold on to it for a second. Let's correct this one first, and then we'll give that one out. That's no problem. Yeah, just gonna have a bit of a head start on it. All right, guys. Let's talk about this item here. So we had to find angle X, which is all the way to the back of the circle at the circumference at R, and then on the opposite side we have angle Y. Now, for those who may have seen it, we have, as we saw before, a cyclic quadrilateral. And X and Y are opposite angles, which means that they are supplementary. So it means that they add to 180. So if we find either one of them, we could simply subtract that from 180 to find the other. So which one do you think you want to find here? X or Y? Which one might be easier to find? We could find Y. Yeah. What was the first thing we had to find though? What about this one here? 19. And then that would facilitate finding the angle here, right? Right? I want to find that angle. Let's just call it theta for now, right? You could automatically find X, because X sorry, theta is 2 times x because theta is the angle at center. And the angle at center is double the angle at the circumference. All right, and then you could go the long way and you could find the remainder here and then find half of that to find y. But once you find x, you could subtract x from 180 to find y because x and y are supplementary. All right, so let's start by finding, go ahead. Nope. Look here. The angle at center. If we were to rotate this way, you see it there? Right? So when you find the angle theta, that's double the angle at the circumference there. Make sense? You seeing it? All right, cool. All right. Okay, well, we know what to do to fix it. Okay. So first things first, let's find that let's find theta, right? So theta would be equal to 180 minus 19 by 2. That's 38. 38 from 180 is 142. Right? And we could state there, let's call it 1, that AOB and ATB are supplementary. Angle AOB and ATB are supplementary. Right, which means they add up to 180. Right, and now that we found theta, we can find x quite easily. Right, so x is equal to 142 divided by 2, which is equal to 71 degrees. Right, that's because angle at center is double the angle at circumference. Sorry. I'm trying to write an at sign there. And then to find y is a simple matter of subtracting that from 180. So y is equal to, 180 minus x, which is, we just saw is 71, right? So we get 109 degrees, not to the 6th power. And this is because opposite angles of a cyclic quadrilateral are supplementary. Now, if you had to specify why these two angles were 19 degrees, you could state that the two triangles, you could say OAT and OBT are what we call congruent, right? That's because these two sides are equal in length, these two sides are equal in length, and they share a common side in the middle, on top of which this is 90 degrees on top of here, and there's 90 degrees below here. So those two triangles are identical. Right, which means that all the angles, well, they're congruent, which means all the corresponding angles are equal. All right. Kiyomi the king. Nice one. All right, Google Meet. If you are good with number 10, just kindly give me a G in the chat. If you need me to re-explain anything or everything, let me know. All right, cool. All right. OB and ACB. No, this is the next question. Yeah. In this diagram here? Give me a sec. I'll go back to that and check, right? X and Y. X and Y wouldn't be equal, no. But that triangle, as you probably realize, hold on just now, is isosceles, eh? But come the man, Philip, behave yourself. Right. But this side is OA and that's OS. So those two sides are equal. So the angles opposite those sides. So for example, this angle is opposite the blue side, and this angle opposite the blue side. So Z and Y are equal. Hey, Rose Green, how you doing? Milo T Lover forever. Good night, everybody. Good night, Milo. Good to have you on. Thanks for joining. All right, this is 11, right? Right. 180 minus 23 by 2, then divided by 2. Right. So, yeah. Right. And then 180. Yeah. 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 That's perfectly fine. I have a test on a big topic, indices. This is a nice topic. I did that in the July August sessions in both my form 5 classes. Yeah. But yeah, you're correct. It's a big topic. Right. So a little technical difficulty. So you can see I have one capture card there, and I have a next one in the corner here. Now here's the thing. This gray one was originally connected to this laptop, right? And this black one was connected to this laptop here. But for some reason, if I connect this, up to yesterday it worked, right? If I connect this to here and this one to here, they don't work. But if I switch them, they work. And up to 2 years ago, Monday, the original configuration worked. Anybody have any idea what's going on? I am very curious because my technology and codes these days seem to be very temperamental. Does anybody have any ideas as to why this one would work in this computer but not in this one and vice versa? Let me know. Ready? Or in a minute do again? Alright, cool. What do you think? I need to put that. No plus. No. Really? All right. Follow me on this one. Let me So anybody notice when I drew this right angle here? Right. So what we could do, we could focus specifically on the triangle at the top, right? What kind of triangle is that? All right, why? Because the angle between tangent and radius is 90 degrees, right? Okay, cool. So first of all, let's actually just notate that, right? So angle OAT is equal to 90 degrees, and you could say angle between tangent and radius, right? Okay, which means that we could find x, because if you take x and you add 23 and you add 90, we get 180 degrees, because the angles in a triangle sum to 180. Right? Which means that x is equal to 180 minus 113 degrees, which means 67, yeah? Right. Now, that's that triangle there. If we zoom in, and we now focus on, like I was saying, hold on, sorry. This triangle here, right? What we would notice is that OA and OS are radii, and all radii in a given circle are equal in length, which means that we have what kind of triangle there in OAS? It's an isosceles triangle, which means that angle Z and angle Y are equal. So, how will we find angles Y and Z if we have angle X? Right? That's correct. Right. Nah. Don't look like one. It is one, but this side and this side are equal. Oh, nah. Right? So base angles of an isosceles triangle are equal. Therefore, Y and Z will therefore be equal to 180 minus 67 divided by 2, which is 113 divided by 2, which is 56.5 degrees. Anybody? All right, cool. Okay. Hold on. Okay. All right. Google Meet, just give me a quick GNU chat if you're good with item 11. Please and thanks. If you need me to re-explain anything, let me know. Oh, yes, I got a good crack there. It's a bad one. Yeah. All right. Try this up to the burn. All right. In class, people, are we okay with this item here on the screen? Yeah. Any questions? Anybody? Anything? We good? All right. Cool. All right, Mishka, I have number 12 printed out there. This is 13. 13, they want us to find ACB. I know. Sorry, I'm going back there just now. Right, so we want to find AOB, which is this angle here. I want to find ACB, this angle here. Oh, break, oh, vibes. Yeah. Hmm? Yes. Right. It's not, yeah. Slick John Roberts. Vibes. All right, let's take a crack at this one here. Okay, so we know that this angle here is also going to be equal to 33 because of the nature diagrams, right? TA and TB are equal in length, as are OA and OB. The angle here is 90, the angle here is 90. Okay, honey, pause here. Bye. Right, so we have identical triangles, right? Congruent triangles to be more specific. Right, so we have 66. So x is equal to 180 minus 66, right? And that's 114 degrees. Right, and we know that's AOB and ATB are supplementary. Always on point. Not R and R. Okay, and then define y, that's just half of 114, right? So 57 degrees. Right? Angle at center is equal to double the angle at circumference. Okay. Google Meet, just give me a quick Genie try to figure out those two items, please, and thanks. Hey, Jabari, good to see you. Okay, 3 out of 5, next 2 out of 4. All right, there you go. All right, in class, people, are you okay? Number 12. All right, yeah, Mish, can you give us number 13? All right. Oh, sorry, yeah. Not Narin R. Oh, not Narin. Okay, good. Right, so we drew in the radii, so 57, and then that one is that, and then by half of here. So 180 minus that, then divided by 2. Yeah. It says draw the radii from the center of the circle. That's the center. Like that. And
Yeah.
yeah, and so. Next and so. Cool. I thought this was it. Hey, Abby, you're going on. Evening.
Chris, you want a baby now?
I have enough babies already, thanks very much. Hey, Rissa, how you doing?
Okay. So this one, find the side, and then half into this. Yeah, 1, 2, 3, 4, 5. Hang on a minute. Hang on a minute. I think so, yeah.
Hey, Rissa. I cool, Rissa. Trying to be good. We can do some circle geometry stuff here. And I'm going to correct this one. All right, you ready with this one? So we had to find angle ACB. Now we know that the angle at center here, O, we know that angle, let's just call it theta for now, right? It's 180 minus 57 because those two angles are supplementary. Hey, Janai, how you doing? And then we know that this angle across here is half of that theta. Right, so let's just condense the working for the sake of simplicity, right? So angle ACB would be equal to 180 minus 57 and then divided by 2. So that's 123 divided by 2, which is 61.5 degrees, right? We divide them by 2 because the angle at center is double the angle at circumference. And we subtract them from 180 because these two angles are supplementary. Okay, how are you doing? Is that right? Okay. When exams happening? One already? Oh, okay, how it was? Normal? Alright. Well, let me know how it goes. And if you get a copy, bring it back. We wouldn't mind a copy of the paper. If you get it back, we wouldn't mind seeing it. Alright. Okay, in class people, we okay with that one? All right, Google Meet. If you're good with that, just kindly give me a Genie chat. Please and thanks. Right. Okay. Right. Yeah, Mish, get have a number 14 to give out when you get a chance, right? So number 14, we gotta find angle C. Right. So, Asia. Hey, sorry, come back. Hey, is Sadhana, is her name? Sadhana. Hassan Minhaj. Hey, so vibes. Calls Cloud vibes. Hi, Paige. It's supposed to touch the circumference. Sorry, yeah. Yeah, that point C there is supposed to touch the circumference. Sorry. My bad. ACB. Yeah, ACB. Well, the one thing I was hoping you would catch on to was that you again have to draw into radii. 1, 2, 3. Right, so from here, right, if you're drawing it to radii, that might unlock the question for you. Right, so if you find that sometimes you have not enough lines or whatever the case is, put in some more. Yo. Oh, she was away? Oh, that's why I didn't see you guys in driving on a morning, by the way.
But I was at school yesterday.
Okay. Yeah, because I got tied up because it's only after, remember, your car is 5401, right? Right. Because there's a same blue CRV, 5961. What was that? 5961? I saw it parked up in the, you know where Fukiang is? I mean, right, opposite Fukiang in the plumbing place, like for a while yesterday. Okay. Okay.
I saw you twice.
Now, what car it was? If I don't know, I wouldn't see you. Yeah. Right, so from here, we could find the theta. And from there, we could find the angle to the back. They call that alpha. And then we could find half of that to find C. Right, so let's see. Right, so to find C, right, so first thing, so C is equal to, let's just call it alpha, which is that green angle in the center, divided by 2, because the angle at center is equal to double the angle at circumference, right? And to find alpha, that's equal to 360 minus theta, because angles at a point sum to 360, right? And then to find theta, that's equal to 180 minus 58, because those two angles are supplementary. So that's 122. 360 minus 122 is 238. And 238 divided by 2, I think, is 119. Yeah. I guess I'm a little tired too because I'm not writing any rules. But I think by now you should know which rules apply to what. Okay. One more for you. But before we get to the one more, I want to know if you have any questions on what I have on the screen there. Come the man, Philip. Alpha. All right, that's just a different symbol called alpha. Okay. All right, guys. So I don't know if we have enough time for the last question, but y'all actually got further than the people last year because last year we didn't get this far. I had to skip out some questions actually last year. Anyhow, every year is different. Okay. Right. Before panic sets in, let's analyze the diagram first, right? Okay, you all see in a triangle, in a circle, yeah, but not much of it. I watched a couple episodes, yeah. Who, me? Oh. I know, Bill. Right, so are we seeing a triangle in a circle in a triangle? Right. So we have a shape and a shape and a shape. Now, tell me something. What do these little strokes on those lines mean there? Right. So it means that this triangle, ABF, is what kind of triangle? We've seen double strokes here. What does that mean? That this triangle is also isosceles, and this triangle here is also isosceles because you have triple strokes. Now tell me something. If you focus on the outer triangle, right? What's the sum of the interior angles of a triangle? 180. And we have 1 and 2 of the angles, but not the third one. So we can. Right. Yo. 54 and 58 is 112. 112 from 180 is 168. That's correct, yes? Andy, where vibes? Now, after you find angle P, check what I want you to find. On the diagram on the screen, I drew in the pink angles are clearly equal because they are base angles of an isosceles, as are the green, as are the blue. So like I said, you could find those angles. And I'm going to add in one more thing for you to find here. I want you to also find angle S. Right, so I gave you a fourth item to find there. Yeah. R equals how much, sorry? 66. Let me see. So we have 68 there. We have 58 minus, that is 122. 61? No, 61? 58. Just now, 122, 120, that's 61, right? Let me check it again. 54 minus, that is 1, that's 63, right? That's 60, that's 1, that's 56. 56 and 63 is how much by 119? Yeah, 61 degrees. Find the pink angles, find the green angles, find the blue angles. And then remember, that this is a straight line. Oh, come on, man, Philip, give yourself. There's a straight line here, right? There's a straight line here, right? There's a straight line here, right? And what's the angle on a straight line equal to? 180 degrees. So if you find the blue and the green up at B, you can find Q. If you find the pink and the green up at Q, you can find angle Q. If you find the blue and the green by R, you can find R. And then when you find Q and R, you can find S. Or you can find the pink and the blue and find S. Alright, I'll tomorrow then. Huh? 58 from 180 is 122, 61, yeah. Okay, I'll see you next week. Bye-bye. So tomorrow, the boys come in, and Mishka says she'll come to help with right. But Mia not coming tomorrow, so it might just be Drew and Sarah. If either of them show up. Yeah. Yeah. No. Yeah, yeah. Yeah. I asked him before he's done. Well. Huh. Right, so to find the pink angles, that's 180 minus 50 divided by 2. That's 122, that's 61 degrees. To find the green, all right. That's 120, that's 63. And to find the blue, 112, that's 56, right? Right, so that's 56, 56, 61, 61, 63, 63. So to find Q, you got to add 61 and 63 and subtract from 180, right? Yeah. You'll notice that the angles inside the inside triangle are equal to one of the pink, blue, or green, eh? 61 and 6, okay, that's 60. Next one, that's 56, right? R, 56 and 63 is 119. 119 minus 61. Yeah, that's the pink angle, not so? And 61 and 56 is 117, so we need 63 here. Right, so just by the way, what we see in here is actually the next rule we're going to encounter on Monday. It's not going to look so complicated. But this line here is a chord. And this is a tangent. And there's a rule that says the angle between tangent and chord is equal to the angle in the alternate segment. So that's why this angle here equal to this angle here. This angle here equal to that angle here. And this angle here equal to which one? No, sorry, hold on. Yeah, this angle here equal to that angle here. Right? When we come on Monday, I'll show you all that in some different examples, right? Anyhow. Yeah. The angle between a tangent and a chord is equal to the angle in the alternate segment. Right? Basically what it means, let me show you, right? Yeah, a circle. Let me say you have a tangent and you have a chord, right? If you were to build a triangle on this chord, right? The angle here between tangent and chord is equal to the angle in the alternate segment. Right? And this angle here, between tangent and chord is equal to the angle in the alternate segment there. Alright, so folks, we're going to put a pin in it there for today. If you have any questions, I didn't get an actor in class, anything still nagging you, you're not sure, but let me know. Send me a pic on WhatsApp, let me help you out. But that's it for today. So I'll see one or later tomorrow for AdMats. The rest of you all have a good weekend. If you all, I know you all send me some messages regarding stuff you want to revise for exams. I will try and send it tomorrow. If you don't see it, message me. Yeah. Yeah. What's happening now? Alright. Like plain old bad debts or provision for bad debts? Yeah? Yeah, whatever they want, what's happening?
You have to